Example 2, we're being asked to use the limit to find the instantaneous slope of x minus 1 all squared at x equals 2. So I've drawn the graph here. At x equals 2, we have a coordinate at y equals 1, and we want the slope of that black line. So again, we're going to choose some arbitrary point close to 2. We're going to call that 2 plus h, and then we need to find the y coordinate for that point, and that's going to be 2 plus h minus 1 all squared. So once we have this set up, what we're going to do is we're going to approximate the black slope with that secant line in here, and we want the rise and run of that secant line. So the rise of that line is going to be the difference between the y coordinate of 1 and the y coordinate of 2 plus h minus 1 all squared. And then the run here is going to just be h, because the difference between 2 and 2 plus h is just going to be h. And using the rise and run, we're going to use a limiting value to find the instantaneous slope. So it looks like this: the limit as h approaches 0. So what we're going to do is bring that green line closer to the green dot closer to the black dot, and we're going to end up with 2 plus h minus 1 all squared minus 1, that's my rise, over my run. Okay, so working this out, we're going to simplify the brackets first. So 2 plus h minus 1 is just going to be 1 plus h squared minus 1 all over h. Expanding that out, we're going to be able to get rid of the minus 1, and that's going to allow us to divide out the h, get rid of that divisor of h, and which will get rid of my divide by 0. So we end up with 1 plus 2h plus h squared minus 1 all over h. The minus 1's cancel out. 1 plus 1 minus 1 cancel out. And so we end up with the limit as h approaches 0 of 2h plus h squared all over h. We can cancel those factors out, one of each. And so we're left with the limit as h approaches 0 of 2 plus h. And plugging that in, h is 0, we're going to end up with a limit of 2. So that means then that the instantaneous slope of that red triangle is going to be 2. So the second part of this question asks us to find the equation of tangent line at x equals 2. So at x equals 2, y equals 1. So then using the point slope form, we end up with y equals x minus 2, y1, y is equal to 1, and then we just have our slope